Yes, class, am I audible to all of you?
Yes, ma'am.
So who all have joined? Amna, Austin, Deborah, Fadil, Humam, Tarif, Rajita, Shahid, Shavez, and Sidra. All right. See, class, in the last class on Sunday, we had started with apparent depth. We had completed this topic. Just this one question was left. So apparent depth and real depth we did. So there was a relation between apparent depth and real depth, with involvement of refractive index, and shift was the last topic that we discussed. So basic relationship is this: apparent depth is equal to real depth divided by the refractive index, and shift is equal to real depth into 1 minus 1 by n. We did a question based on this, but we didn't do any question based on this. So let us see that. So I hope you people have written this by now. A mark is made at the bottom of beaker and a microscope is focused on it. Microscope is raised through 1.5 centimeter. To what height must water be poured into the beaker to bring the mark into focus? If you have to bring the mark into focus, it means you have to find out the change in length that has occurred, right? The shift that has occurred. How much you are bringing, how much you are raising the mark in order to make it at focus, in order to be it visible, because it's not visible from every length, right? So here also it's like you are drifting it. So shift here will be, formula of shift is d real 1 minus 1 by n, where n is the refractive index. So here refractive index of water is already given 4 by 3. Then we need to find out what is the shift. Shift is given, no? Shift is focused on it. Microscope is raised through 1.5 centimeters. See what is happening. Mark is made at the bottom of beaker and microscope is focused on it. Now, in order to see this mark clearly, this mark, to make this mark visible, to make this mark clear, microscope is shifted by 1.5 centimeters. So it means this is the actual shift that is occurring. Now it says, to what height water must be poured in order to bring the beaker back to focus, right? To bring the beaker, to bring the mark into focus. It means what is the actual separation? What is the real separation into which you have to pour the water? You will not pour the water, no, up to apparent depth. You will pour the water totally. I'll show you with the help of this diagram. Wait. It's like, look, this is a beaker. I have to pour in water. So when you are pouring in water, you will start pouring it from the last layer. No, you cannot pour the water in air. You have to pour it totally. Suppose there was a mark made. And to this step, you are able to see the mark. So the shift that has occurred, no, in this earlier, when we were focusing the microscope at this point, we were not able to see it. So microscope was adjusted and it was raised by 1.5 centimeters. It means this is the shift that is occurring. You can also see this is the shift that is occurring. So we have shifted it. But actually we want to know that how much water has to be poured in it. It means what is this entire length means real length. Real depth. It means real depth. What is the real depth? So shift is also given to us as 1.5 and n is also given to us as 4 by 3. So see, 1.5 is equal to d real 1 minus 4 by 3. So 4 by 3 will go up. So from here you will find out 1.5 is equal to d real 4 minus 3 by 4. Now this is multiplied. Wait. That becomes 1.5 is equal to dr into 1 by 4. So real depth is equal to 4 times 1.5, which is equal to 6 centimeter. Why in centimeters? Because 1.5 was also written in centimeters only. So this is how you have to use the formula of shift also. Only this was left. Now we'll start with TIR, total internal reflection. Write down this, those who have not written the question. See class, now the next topic, that is total internal reflection. So first understand the part, then we'll read out the statements. See, this is, let's say, rarer medium. This is denser medium. Now light ray, first point that you have to keep in mind whenever we are talking about total internal reflection is that light is moving from denser to rarer. So let's say this is the incident ray. This is the incident ray. If this is incident on it, here we'll have the normal reaction. Suppose the normal refraction occurs. This was the angle of incidence. This is the angle of refraction. Normal case of refraction which we have been studying. Correct? This is how we have been studying. Now see, now what happens? This angle of incidence increases a bit. Means this ray is shifted towards the horizontal. Fine, the angle of incidence increases. So what is noticed? It's noticed that this angle of refraction also increases. Now see class, this was the first case, second case. Now look at the third case. If I increase this angle even more, what will happen? The refracted ray will also tilt more. Initially, it was like this: incident ray, refracted ray. Increase the angle of incidence. This also increased. If I'll increase it more, it will become like this. If I will increase this more, this is the angle of incidence. I have increased this more. This angle of refraction comes here. That is, this exactly becomes 90 degree. This is the refracted ray. Now this angle at which the refracted angle becomes 90 degree, this particular angle, this angle is called as the critical angle. What is this angle called? Critical angle. What happened? We have exceeded the angle. Now one critical angle, that was a minimum angle which was required, that is reached. So this refracted ray, which was tilted at certain angle, now this becomes completely 90 degree. This is overlapping the horizontal. Fine. This is the third case, which is a unique case to remember. Now look at the last case. Suppose I have exceeded this critical angle also. Now this angle which I am talking about, this angle is greater than critical angle. I have exceeded this critical angle also. I have exceeded even more. Now where will the ray go? This was the maximum limit for the refracted angle to be present because it is overlapping and there is no space left. Interface has reached, right? Now if you will increase the angle even more, the angle reflects within. This is actually refraction occurring. You can see this entire. But here what has happened? Because once the angle, critical angle has exceeded, here the critical angle which was present, this has exceeded. So this ray which was present like this is going now further down. So this is the angle of refraction. But this actually is reflection occurring. This angle, that is angle present, is equal to this. All the laws of reflections are followed. So can you see? It is totally internally getting reflected. This was actually refraction which was occurring. Now what is happening? Internal reflection is occurring. This phenomena is known as total internal reflection. Now I'm repeating this entire concept. Understand this first. All right. And whatever doubts you have, let me know. And I'll be asking you questions right here. Because this comes as a theory part also to write. You have the derivation also for it. And you have the numericals also from this. And tough numericals are there even in your NCERT from total internal reflection. So be careful. So see, what is meant by total internal reflection? Austin, am I audible to you? Austin, reply with a yes or no in the chat column. Your mic doesn't seem connected. Austin? Is it audible? All right. Other students listen. I think he has not responded. His mic is also not connected. Chavez, screen is visible to you? Chavez? Chavez? Yes, Chavez. I'll remove them.
Ma'am, excuse me. Can you please explain this briefly once again?
Yes, Rajita, I'm explaining this. I'm repeating this. I'm just checking some students. Some are having network issues. Sidra is able to see. Chavez and Austin. Alia, is it audible to you?
Yes, ma'am.
Okay. Just a second. All right, class. See, now understand the concept of total internal reflection. I'll ask you here only this time. See, when a ray of light, the first condition is that the ray of light has to travel from denser medium to rarer medium. This cannot be reversed. First thing, remember this. From denser medium, the light ray is traveling to rarer medium. All right, this is the first condition for total internal reflection to occur. Secondly, what happens? Initially, in this first case, incident ray is present. There's an interface which is present between rarer and denser surface. So refraction occurs. Simple refraction phenomena. Nothing has occurred over here. Now I have increased the angle a bit. So what am I noticing? That when I am exceeding a little angle, the refracted angle is also increasing. Fine, till here it's fine. The first two cases are very easy to understand. Here I'm just extending this, and this is also getting inclined. It's like if it was like this, it's like this. Fine. Now, I have increased the angle a bit more. And at that angle, I am noticing that the angle of refraction becomes 90 degree. Means this ray has completely overlapped. It was tilting, angle was increased up to 90 degree. That is completely overlapping with the horizontal, with the interface completely. Okay, Austin, okay. Chavez, I have still not received his response. Okay, yes. So I was saying, so at this angle is received when I'm noticing that angle of refraction becomes 90 degree. Fine. Now this angle for which the angle of refraction becomes 90 degree, this is known as the critical angle. Third part is clear? What happened in the first case? In this part, here angle of incidence came. Two different media are present. Interface is there. Refraction occurred. Simple. Fine. In second case, I increased the angle of incidence, so angle of refraction also increased. Clear? In the third case, I have exceeded this incidence angle to a certain value, that angle of refraction here in the rarer medium becomes exactly 90 degree. So this angle has a specific name which we call as the critical angle. Fine, this angle is known as the critical angle. Now, when I am exceeding this further, it means I'm making the angle of incidence greater than the critical angle. This was the critical angle for which angle of refraction was 90 degree in the rarer medium. When I am increasing the critical angle in the denser medium, means angle of incidence is greater than critical angle. What is happening? The ray of light, which was supposed to be getting refracted, now is getting reflected because of the criteria that critical angle has been crossed. Critical angle was the maximum value. What is critical angle, class? Critical angle is the angle of incidence in the denser medium for which angle of refraction in the rarer medium is 90 degrees. Clear? What is critical angle? I am repeating. Critical angle is the angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees. This is fixed. For every critical angle, angle of refraction will always be 90 degrees. You won't change it. Fine. For every, even if you take any component, any media, any ray of light, for the angle, critical angle, angle of refraction will always be 90 degrees. All right, this is fixed. Now, once this critical angle is crossed, the ray gets reflected in the denser medium itself. So what are the conditions for this phenomena is known as total internal reflection. In the last part, no, which we see, where angle of incidence is greater than critical angle, the ray of light gets reflected internally in the denser surface. So this phenomena is called as total internal reflection because this is getting internally reflected, no? This was supposed to get refracted, but within the internal surface only of the incident ray, refraction has occurred. Now, what are the conditions for total internal reflection to occur? First is that incident ray should travel from denser medium to rarer medium. First medium is clear. First criteria is clear to all of you. Ray of light should always travel from denser to rarer medium. If vice versa is occurring, then total internal reflection will not occur simply. Fine. Second condition is that angle of incidence has to be greater than critical angle. If it is up to critical angle, it will always remain 90 degree. If it is less than critical angle, these cases will occur. Until and unless it is more than critical angle, total internal reflection will not occur. So two conditions. First, from denser to rarer, the incident ray should travel. Second condition, angle of incidence should be greater. And what is angle of incidence? It's the angle of incidence in the critical angle is the angle of incidence in denser medium, for which angle of refraction is 90 degree in rarer medium. Till this part, is it clear to all of you?
Yes, ma'am.
Yes, Humam. Tell me one criteria for total internal reflection to occur. Just one criteria. Any one criteria, Humam, for which total internal reflection can occur?
Denser to rarer.
Denser to rarer medium. Good. The light ray should always travel from denser to rarer medium. Fine. Rajata, second condition.
The angle of incidence should be greater than the critical angle.
Perfect. Second condition, angle of incidence has to be greater than the critical angle. Then only total internal reflection can occur. Tarif, what is meant by critical angle? Yes, Tarif. What is the definition of critical angle? What is critical angle? What have you understood about it?
Sir, angle is the angle which the light passes through a denser medium to a surface of a lesser density.
Yes, Tarif. What is meant by critical angle?
Critical angle Is the angle where a light passes through a denser medium to a lesser dense medium.
See, critical angle is the angle of incidence in the denser medium. Okay. Critical angle will never occur in the rarer medium. So angle of incidence in the denser medium, for which angle of refraction is 90 degree, you have to specify that angle of refraction is in rarer medium. All right. Now see, let us read the statements. The phenomena in which a ray of light traveling at an angle of incidence greater than critical angle from denser to a rarer medium is totally reflected back into the denser medium. This is called total internal reflection. And what is critical angle? Angle of incidence in the denser medium, for which angle of refraction in the rarer medium is 90 degree, is called critical angle of the denser medium and is denoted by the symbol I with small c in the subscript. Derivation. See, the derivation for total internal reflection, you don't have as such derivation for this. Here you have to apply Snell's law. Let me tell you this so that we can straight away go into the questions. For critical angle to occur, no, we will apply Snell's law. Now suppose this is rarer medium, I'm taking the refractive index as NR, not 1, 2, because that will be confusing. NR and ND. This is ND, this is NR. So Snell's law, what we have studied about Snell's law. I'm repeating, those who do not remember, learn it right away only, because this Snell's law will be used ahead also. See, if this is NR, so NR into sin R means take the refractive index into sine of that angle of that medium. Whatever is the refractive index into sine of whatever is the angle. So here we have NR into sin R equal to the opposite one, ND into sin I. If you use this, so according to Snell's law, NR into sin R is equal to denser into sin I. Right here, the angle of incidence we are referring to IC. For total internal reflection to occur, we are talking about IC. Fine, critical angle. Now see, what is the angle of refraction for critical angle? Angle of refraction is 90 degree, right? So it means this is NR into this becomes sine 90 degree is equal to. This is equal to ND into, and sine I is sine IC, critical angle. So what is critical angle equal to sine IC? Sine IC will be equal to, this is one, NR by ND. So NR by ND, ND by NR, we write it as NDR. ND by NR, we write it as NDR. So how will we write this? Sine IC will be equal to 1 by NDR. This is the formula. That's it. In the derivation, you have just this. You just have to remember these. We'll see questions also. But first write it down. Then I'll discuss the questions. Yes, Tarif. See, Snell's law is you have to take the refractive index of the medium and multiply it with the sine of that angle which is formed. So suppose here we saw that refractive index was of the rarer medium. So which angle is formed here? R. So NR into sine R. This is equal to here, this is denser medium. Here the angle is angle of incidence. So ND into sine I. If suppose I'm talking about this case, here I had taken critical angle case, no, in the derivation. So NR into sine 90. So sine 90 is 1. So NR into sine 90 is equal to ND into sine IC, critical angle. That's what I have written. This is the case. This is the third case which I have written. Class C, this question, calculate critical angle for glass air interface. For glass and for air, you have to remember the refractive index and water also. Glass, air and water. Because I've seen in most of the questions, these three are not mentioned. So it's better if you remember these values. Water, you have just done that question also. Now see here, critical angle for glass is air interface. So critical angle for glass, the angle refractive index for glass is 1.5. All right. And for air, this is 1. It is taken as 1. So here, this is the denser medium. This is the rarer medium, right? So sine IC will be equal to 1 by NDR. Let's calculate NDR separately only. Then we'll substitute it here. NDR will be equal to ND by NR. So this is 1.5 by 1. So sine IC will be 1 by 1.5. Critical angle will be sine inverse 1 by 1.5. This is the answer. But the point is that for this, you have to remember this. If you do not know this, you won't be able to solve that. Write it down. Next question is a little lengthy. So write it down. Then I'll show you the next question. See class, in this question, this incident ray strikes on this surface, then it gets refracted. But at this point, this must be the critical angle. That's why the angle of refraction over here is 90 degree. If you see, the angle of refraction is 90 degree. This is critical angle. This here is forming 90 degree. This is angle of refraction. This is A point. This is B. This is C. This is D. Refractive index of this material glass is taken as N in this question. It's given in the question. Let's say this point is P. This point is M. This point is N for the triangle formation. Now see, at this surface, BC interface, if at this surface, if I will apply Snell's law, here the angle is I, so sine IC. And what is the refractive index of this medium? N. So N into IC. Okay, Austin. So N into sine IC is equal to, what is this medium? This is air, and refractive index of air is 1. So 1 into sine R. Now sine R is also, this is also sine 90 degree, which is equal to 1, because this is critical angle as we have seen in the figure. So basically sine IC is equal to 1 by N. Keep it safe, we'll use it later. Now come to this surface AB. Here also we can apply Snell's law. This is air. So 1 into sine 70 is equal to, what is this medium? N into sine R. At this point we are applying Snell's law. So 1 into sine 70 is equal to N into sine R. This is clear, the application of Snell's law. If still it's not clear, please let me know. I'll repeat it. I'll tell you how am I writing these equations. Medium is refractive index. Here is 1. So 1 into sine 70. And here the refractive index is N. So N into sine R. Fine. Okay, one more thing. In the question, no, this was given. Value of sine 70 degree was given in the question. 0.9397. This was mentioned in the question. I forgot to write this. Now see class, from here if I write sine R will be sine 70, that is 0.9397 divided by N. I have sine R. Now if you look in this triangle MNP, sum of all these angles R plus IC plus this 90 degree, according to angle sum property of the triangle, in the triangle MNP, R plus IC plus 90 degree will be equal to 180 degree. Here in this question, you have to find out critical angle basically. So IC plus R will be equal to 90 degree. So what is R equal to? R is equal to 90 degree minus IC. Fine. Now, what is the value? Just put this value here. Sine R is this. Put the value of sine R. This becomes sine 90 minus IC. Why? Because sine R, and R is this, is equal to 0.9397 divided by N. Class, sine 90 minus theta is equal to cos theta. That is cos IC. This is equal to cos IC. So this is 0.9397 by N. Now see class, cos square theta plus sine square theta is equal to 1. So what is sine square theta equal to? 1 minus cos square IC, right? And what is cos IC? Cos IC is this. So cos square IC will be square of this term. Look here. Sine square IC is equal to 1 minus 0.9397 square by N square. Correct. Cos IC is this. So cos square IC will be square of this. Now what is sine IC from this? Sine IC is equal to 1 minus 0. Let's write it as 94. Continuously we are writing the entire term. By N square under root. Fine, this is it. Now, what is sine IC? Remember, initially we have calculated this. Sine IC is equal to 1 by n. And we have finally reached to this point where we have to write about sine IC. So sine IC is 1 by n is equal to 1 minus 0.94 square by n square. This is it. So this will be, let's square this. This becomes 1 by n square is equal to 1 minus 0.94 square divided by n square. So if you bring this term here, n square denominator common, this will be added up. 1 plus 0.94 square divided by n is equal to 1. So from here, n will be equal to 0.94 square plus 1. This is equal to 1.88 n square. So n is approximately equal to 1.88 under root. So IC we have to find. Sine IC is equal to 1 by n. So IC will be equal to sine inverse 1 by root 1.8. This you can complete it. You can always find it. Main thing was to remember this was just mathematical calculation till here. Till here you had to remember how to convert, how to apply Snell's law. Write this down. It's a lengthy question. Wherever you get stuck, let me know. I'll repeat. This right angle triangle. See, Harry, this is already given in the question. In this triangle, this is angle of refraction because angle of incidence has fallen over here. And since this angle of refraction is 90 degree, this tells us that this is angle of incidence. So when we join this becomes a right angle triangle with 90 degree here, the angle of refraction here, and angle of incidence here. Tomorrow we'll continue the rest. This is almost completed, total internal reflection. Tomorrow we'll complete with spherical refracting surface. You all can leave. All those who have their